Hello and welcome to tonight's webinar where the focus is totally on geometry. Tonight's presenters are Rodney Anderson and from sunny Brisbane and John Beaumont from sunny Darwin. Both Rodney and John are passionate maths teachers who have years of experience of using technology with the purpose of deepening student understanding. So I'm very excited to see what they're going to show us today. And I'm Daisy Patsis from not so sunny Melbourne. During this webinar, feel free to communicate with both myself and the panelists. I do monitor the incoming communication, and I will endeavour to answer the question as it comes in. If we don't get a chance, we certainly will do so after the event. I think that's enough from me as an introduction, and we'll hand over to John now for some exciting things to get us started. Over to you, John.
That's a bit daunting, isn't it, when you say that, Daisy? Pressure's on now. Good evening, all. I'm just going to share my desktop. And on my desktop here, I'm actually going to use my iPad. It should go to full screen. Why is it not going to full screen? There we go. That's better. Beautiful. So yes, tonight my good friend Rodney and I will be using various TI-Nspire platforms. I'll be using the iPad app, as you can see on the screen now, and Rodney will be using the teacher software and the handheld emulator. I use the iPad app with all my students from years 7 to 12, as well as the handhelds. And I especially like using it with geometry. We can see that. Let me just draw a shape. So here's a little circle. The reason I like using the app and even the dynamic geometry on the handheld is that the students feel that they're actually controlling it, and they feel that by touching it, even though it's only a two-dimensional screen, they still feel that they have control over what they're doing, and they can quickly see what's happening. Notice that you may see that you can see a yellow dot, which represents my finger. I find that really useful in my teaching because when we're using the iPad app, the students can't see what actually I'm touching on the screen. So to set that up, if you have the app, if you go to the home screen and the cog in the top right-hand corner, you click on that, you can show touch. The third one down allows you to show the touch functionality. There's a nice little trick there that Peter Fox showed me once. How nice is that? Okay, so going back to what I was doing, notice that when we choose, once I chose the spanner, once we choose a shape, notice that it comes up in the right-hand corner. And if we're not sure what to do, obviously a circle is pretty obvious, but if we're doing transformations or other things, it's not as easy what we're supposed to be doing with it. So if you click on where it says circle or whatever that icon up there is that you're using, it will give you basically what I would call the syntax of how that works and what you need to do. The other nice functionality, in the past, this wasn't here. If you watch now, if I draw a circle, that icon, after I've drawn that circle, disappears. And that used to frustrate me because I would maybe want to draw more than one circle. So now, when we go to draw a circle, there's a little padlock right next to the icon. And if you click on that padlock, you can now lock it. And that allows you to draw lots of circles. I remember this from primary school. Do you remember doing this at primary school, Rodney? Did you ever do this at primary school?
Love it.
Hey, beautiful little thing. There we go. I think I've gone wrong somewhere. Oh, I have, look. Oh, there you go. I've got the last one. It used to take me hours doing that by hand. Now I can do it in seconds on the iPad. How about that? The only thing you've got to remember is that if you're trying to do something else, like if I'm trying to move the screen or do something like that, now it won't work because the icon's still on. We just need to press the cross to take you out of that. So that will get me out of that now. And, all right, we can now see that I can move it around. The nice thing about even doing something like this is that you can say to the students, how can I make that bigger or smaller? And the students will try and grab different bits of this. That's interesting, that moves it around that way. But getting them to see how something is made, how it's been constructed, or working out what they need to do to actually make it bigger or smaller. And that's a nice little functionality. All right, let me open up a new page. Another nice functionality that's happened in more recent time is MassDraw, and Rodney will show you this later on the software, the teacher software, and therefore the handheld. There's MassDraw, and MassDraw allows you to draw basically a large variety of geometric objects, as long as they can be drawn with a single gesture. So you can draw a line, circle we can now draw. How good am I going to be with my square? Not bad. And there we go. The nice thing about using this is it's quick. The students, again, feel like they're using their finger like a pen. And it automatically labels it as well, so that when we press the cross again to get out of that, when we grab those shapes, we can easily rotate them and do whatever we want to with them. Is there anything you'd like to add to that, Rodney?
No, it's beautiful, isn't it? Love MassDraw.
Yeah, fantastic. So I'm just going to add another clean page. As my son just walked through the door. All of us trying to balance children at home tonight. And we'll go to MassDraw. And we'll draw a triangle. It automatically labels it. And obviously one of the things that we try and get students to do is to understand the aspect of interior angles and the sum of angles. And we can do this quite nicely on here. So we go back to measurement, obviously measure the angle. Now again, I want to lock that on the software and the handheld. It does it automatically, but on the iPad we have to do it this way. Now we'll measure that angle for me. That angle. Now notice those angles come up as decimals. And sometimes you may, that may be useful if you want more accuracy with the students, but maybe you want it to be a bit more generic. So what we can do is in this functionality here, so in the icon, let me just show you again, the icon 2 across from the spanner, the cog with the graph, you can actually set it so it forces geometric triangle angles to the integers. And if we now delete those, well, let me delete that one. Doesn't matter. So I'll measure another one. We can see, it hasn't let me do integers. What's happened there, Rodney? What am I doing wrong?
Probably didn't slide it across, did you?
Yeah, slid it across. Well, I've embarrassed myself there, isn't it? Well, I'm not sure what's happened there. Maybe the other ones weren't. Maybe that was it. I'll leave that for now. But if you do that at the start before you do it, then it will lock them all. We can see that as I grab that triangle, there you go. As if by magic. It's one of those things that when you're in the classroom, the kids can't do something, and then they say, sir, or, I can't get it to work, and you go over there and it works. It's like it must be Rodney's presence just made it happen, just turned it to integers automatically. Look at that, beautiful. Now we can also we can get the kids to look at that and see if they can add that up themselves, but sometimes it's nicer to get the technology to do it. So what we can do with this is we can add a text box, and we're going to put in the fact that we want to add those 3 angles together. So we're going to do A plus, hold the A down to get the B, plus hold the A down to get the C. And at the moment it's just an expression. If I go back into the spanner and go calculate now, it says select a value for A, so I'm going to choose 81, select a value for B, 36, and select a value for C, 63, and there you go. Adds up to 180. And now, I don't know about you, Rodney, but I think sometimes my kids don't think that that's recalculating it every time. Do yours feel the same, or do they normally go, yeah, I believe you, it is actually dynamic?
Yeah, the girls can see that the angles are changing, but sometimes they see the text in the corner and say, it's not moving, it's not dynamic. And they're easy to convince afterwards, but they often say that. Yeah.
So what I do sometimes as well, like if we rehearse that, Rodney, what I do as well sometimes is I'll add extra measurements to it so they can actually see that happening. And one of the measurements obviously would be length. I'm going to lock that with the spanner, the padlock again. I'm going to measure that length there. AB I'm going to measure, and CB I'm going to measure. And then we can do a similar thing as before. So we go back, actions, add a text box. Let's go X plus U plus Y, enter. And do exactly the same thing again. Calculate, select an expression, value for u, value for x, and a value for y. And this time, they actually can see that when I change it, the actual measurements are changing. So I think that they have a bit more of a, they believe me a bit more when they see the actual, oh yeah, I can see that. The other nice thing that I use this functionality with is also when you're teaching trigonometry, you can also talk to the students that you can say, okay, if I pull point B to the right-hand side, what's going to happen? And obviously most of the time they'll know that AB will increase, but they're not sure, they don't always see that C will increase. And that's a nice example and reinforcement of students understanding a bit more about trigonometry and what effect the angles and the lengths, their opposite lengths, what effect they have on each other. Anything you'd like to add to that, Rodney?
No, it's wonderful, isn't it?
Oh, you say the nicest things, you know that?
Yeah.
So now what we're going to look at tonight is these are the first couple of content descriptors, and I'm taking these from Year 7 that I was going to look at. One was formulas for areas and rectangles, triangles and parallelograms, and the other was corresponding alternate and co-interior angles, both from, like I said, Year 7 measurement and geometry. So if we add a geometry page and we go into actions in the MassDraw again, very nicely we can do our cross of our line so that we can do vertically opposite measurements. Quite easy there. That just slipped my mind for a second. That was a bit bizarre. And we can obviously measure those. Measure the angle, use the padlock again. All right. Get rid of the angle, move those apart. And we can see very nicely how that works. And the other aspect, especially with geometry, that I like to introduce to this is I like to get students to go out and take some photos of whatever area geometry that we're doing at the time. So if I was doing vertically opposite angles, I may either set them for a piece of homework or to go around the school and find some photos. So again, let me start afresh. I've already taken a photo. I was racking my brain earlier today thinking, what could I take? And I went and found my son's music stand, and I thought, there you go, perfect. There's the music stand. That will do me quite nicely. And again, because we've now got the image on here, and I can either use MassDraw, but I can just do a line. Oops, sorry.
Tell the truth, John, it's your ironing board, isn't it?
It's a very trendy ironing board, isn't it? I reckon it's a very trendy ironing board. I like that. You found me out, Rodney. You can see that the black line there doesn't look that great with the black ironing board. Get rid of the cross. Thanks, mate. So you can change the colour with the dial section on here, and Rodney again later will show you how to do that on the handheld. And we can change to a brighter colour if we want to, and we can also change the thickness so we can see it a bit clearer. That's a bit better. And I think I should have done that both at the same time with the other one too. Yeah, that was a bit silly. Should have done both. I can highlight them both at the same time. Just so I can highlight them both. I should have done them both at the same time rather than doing anything else. And then we can measure that exactly the same. So the use of image is really useful. And like I said, I find it really beneficial with obtuse, and acute and reflex angles. Getting the students to go around and even looking for different shapes, different types of triangles and quadrilaterals is really useful. So now we'll just look at, I think that I don't really need to look at alternating. Oh, I probably will. Just trying to think of time and not wanting to eat too much into Rodney. How are we going, Rodney? You got a few minutes?
You've got plenty of time, mate. Keep it going.
Okay, buddy. Thank you. Now the geometry page, and I'm going to draw a line. Now, obviously, if we're looking at corresponding or co-interior, then it's all well and good having the line. And if you want to, don't forget you can grab the end of that line and pull it out longer if you want to. But those need to be parallel. For them to be parallel, we need to go into construction and construct a parallel line. And what I said earlier, that if you're not 100% sure of the syntax of what you should do on a parallel line, obviously you can just have a go and see if you get it right and do the undo button if you need to. But you can just click on parallel, tap the line, and then tap the location of the point through which the parallel line should pass. Okay. There we go. Just grab the ends of those and extend them out. The nice thing, again, about constructing this is when you say to the students, okay, if I grab that line, that bottom line, or let's add some colour to this so that we can talk about it a bit differently. If I grab that red line on the right-hand side and pull it down, what's going to happen? And I found this really useful to do with my students, getting them to think about what's going to happen before it happens. And especially that's much easier if you've just got, you're using the data projector and you've just got you're in control. I think if you give it to them, then sometimes they just don't even have a think before they do it. But as you can see, it won't let me grab it. It won't let me move it. Why is that, I wonder? Oh, okay, because the parallel line is only created by this dot here. I can move the dot, but it still keeps it parallel resisted. The red line's been constructed, whereas this line here, the main line, the line that we made the parallel line off of, we can actually use. And if we grab it there, and we can spin it around. That then allows me, I quite like this functionality, so I'll use it again, to do MassDraw, to draw a line across, and then we can then measure those angles, just like we've done all the other ones so far. There's that angle there, and I didn't press the spanner, did I, to actually keep it in to check for the same one again, and there we go. Notice that I can change what that's rounded to if I want to, by going into the cog up here. That's not really going to be very helpful, and it won't do the integers like it does on the triangle. So I could do exactly the same thing again, and I could actually set up an expression, a plus b, choose those 2 points, and show that equals 180 degrees. Now, Rodney, do I have time to talk about area, or shall I save that for if we've got time at the end?
Maybe you can save it at the end. You can do it if you'd like to, but...
That sounds good to me. Sounds good to me. How about I'll pass over to you, my friend. Is there anything that you'd like to add to that?
No, that's okay. I'll just share my desktop. Well, good evening, everybody. I was quite an enjoyable start after the session with the iPad technology and Northern Territory. Just regarding what John was talking about, the Australian curriculum, like himself preparing for tonight, I actually looked at the Australian curriculum and looked at a few things and just copied, as you see on the screen, using units of measurement, shape. John was looking at these ones here. Then the Year 8 units, Year 9, then on to Year 10, 10A. So what I'm going to do is take a step back and think like a Year 7, Year 6 students, and a lot of people say, why don't we just use these applets on interactive textbooks or websites? And we think, oh, we've got the computers, the students have got their handhelds, they've actually got the software. We could actually, once you can see they've actually using the TI-Nspire Navigator software. So if I have these files, I can immediately send to my girls in class and I'll ask them questions. I can do quick polls. So I'm going to look at triangular areas and areas itself, little things I need to do with my Year 7 students. So what I've got here is actually I've inserted a graphs application, and what I'm going to do now is I'm going to turn on the grid, the dot grid. And I love using geoboards and rubber bands. We've been in schools where the students go a bit crazy, and I say to my girls, play for a few minutes with the rubber bands and then get your creative designs out of the way and concentrate, or sometimes we'll just use it in the classroom environment. Now, in here, I do not need all 4 quadrants, so what I'm going to do is actually go under Window and select Quadrant 1. So I have my dot plot there, the dot grid. I'm actually going to draw a triangle. So I go into the menus. Have you noticed that up here I'm using the menu icon on the software? I could use the actual handheld, which is here. So click on that, and I'm going to actually draw a triangle. Come into Shapes, draw a triangle. And I'm actually just going to click on one point, move across, move up, select that last point, and I'm still in drawing triangle mode. As you see, if you're ever unsure, like John said, move your cursor over the top left-hand corner of the icon and actually give you some hints what you can do for each of those instructions or commands. So let's get out of that. Just press the escape keypad. And I'm here. And I say to the students, what's the area? And the discussion for lower level ability students or just revision, they talk about whole square units. I like students saying square centimetres, not centimetres squared. So we talk about the square units, and then we talk about what happens here with that triangle and happens that triangle and so forth. Can we join them together? And we talk about the area. And as John said, we talk about the colours, so do it as the night progresses. So what I can do, I can come into here and I can actually right-click and I can actually select the line colour. Not being sexist, but as soon as I show the girls that, I've lost them for the next 5 minutes. They love colouring in the lines. They actually love filling in the colours, but they love doing it. Let them play for a little while, then I get them back to concentrate so I can select the colour. And so we say, what's the area? So we go, okay, let's do some calculations. And I often say to the students, you're new to the Nspire, where would you think the calculations are? So we're on geometry before, so we select 8 and we say measurement. And then we say area. Let's select 4. I'll just run my cursor up the top left-hand corner. And then I've selected angle measurement. My apologies. So measurement, area. That would be better. I come up to here. I can click the object, or I can move to the length. So I'll come over to here, and it is actually 6 square units. So I'll just press escape to get out of that. And we can say, how do we get the 6 square units? It's great. Then I say to them, what happens if I actually change the shape of the triangle? So if I grab that point, the area hasn't changed. And they say to me, like John said before, well, the text is just there, it's just staying there. And then what if I just grab that corner and move it down? It changed. So when we talk about how do we work out the area of that triangle? So again, back to the geoboards, or here we can talk about how do you derive the area of a triangle. We have little applets. So one thing I like doing with the area of triangles is thinking about parallelograms and rectangles. So come back to here, what I could do is actually draw a rectangle enclosing my triangle, and you would see that it would be double the area of the triangle. So the area of the triangle is base times height, and that gets a nice little sounding board. In area units, I always go base times height, base times height, base times height for any figure. So a rectangle, base times height, square, base times height. Then all of a sudden we go into triangle. Instead of going length times width, now it becomes base times height. It all goes through that situation. So I'll come back to what I'm doing here at the moment. And we talk about the actual area of that figure. And what we could do then is actually what I did quite a few years ago is some of my attempts to actually create some diagrams. I could actually create a little investigation in my TNS files. What I like to do with my students is actually, instead of being up the board working together, I actually send them files with instructions and they actually work through it. And you'll see it later on with circle geometry I like to do with my students. So we move across. I have got a simple demonstration here of my students, and we're talking about the area of a rectangle and the area of the corresponding parallelogram with this common base and perpendicular height. And I'll say, okay, let's move point E. So I grab point E, and they say, oh, it's not moving, nothing's changing. Okay, let's grab vertex B, it changes. And then I say, okay, look at the same area, why? The question is why. Instead of just standing at the front saying why, they need to think about it. So obviously with the geoboards, and also it comes to here, the magic point, it gets to here, and it goes, aha, the aha moment comes. I should love that as a teacher. John, do you like that in the classroom? And they just click, and they see that there, and they can move it over to here. And I say, all right, what's the area or the formula for the area of a parallelogram? And they say, well, since we're doing base times height, it must be base times height. So we can actually move this across. Same with the senior students. I can use this with the senior students talking about shears. And I probably wouldn't do it this way, but I'll just show you how I constructed it. So I go into actions, I go into hide and show, and the viewers who are watching this will probably analyze and see what I've done. So from memory, I actually put in a line, I created a perpendicular, then I put in a line that's parallel, which I'll show just like John said before, and I created the rectangle, and I kept on going and created my polygon, which is obviously the parallelogram. So if I escape out of that, and that's a lot of things that I like doing with little applets within the classroom. Now, as John said before, talking about...
Sorry to butt in, but it's also quite nice to actually show them that, and then as a piece of either classwork or homework, say, can you create a similar page as this without showing them those constructions lines?
Yeah, and it really reinforced understanding, and as John said, like, make them do it. Instead of us providing information, providing the TNS files, how they create things and do that. Now, as John showed you before, what I might do is insert a new document. So there's many ways of doing with the actual software. We can actually insert it this way. We can insert. We can use the handheld to go control documents. I add a new page. Or sometimes I like just like a computer, because remember it's a little computer in your hand. I can control N for new. And I'll say no. And here I'm going to add a geometry page. And as John showed you earlier tonight, in the software, if I go through to actions, down the bottom, Americans still can't get it right, MassDraw. I wish we could change that to MassDraw. That's just being pedantic again. So I could come into here, and as John said, move up to the left-hand corner. I'll let you have a read. So if I want to add a point, there's my point. I should love it when there's a label attached to the point. If I want to draw a line, so I'm just using the mouse with the computer, so click and drag. There's a line. As you saw John before, I actually have a vertical opposite angles, or what we could do, and let's pretend we got out of MassDraw and we so escape, I wouldn't mind actually having a parallel line. So how do we do that? So we go into the menu, go into construction, and obviously we select parallel. So I need to be aligned parallel to the initial line, move it through to the side, click that, I'm happy, grab the end, make it a bit longer, and let's make it transversal. So we've actually got this parallel line. As John showed you before, by moving that point, we can't move that parallel line to actually move the actual point. And I'm actually going to insert a line segment. And then we have our transversal. And as we say in the classroom, let's measure some angles. So we say to the students, but then students say, oh, that point there's got a B, that point, oh, it's got no letter, there's no letter there. So I can actually label points later on. See this point at the end here? So if I escape, what I can do, I can actually right click. And do you see number 2, we have a label. So we can say label, let's call that D. So we love our alphabet mathematicians, don't we? We have point D. So we can always come back later on and label our points and lines and add points to it and so forth. So enough of that chat. Let's measure the angle. So the students, where would he go? Oh, measurement. They tell me. I'm in classroom, so students like using the arrows. I'm a simple bloke. I like number 6. So I press number 6 in the classroom. Then I'm going to come through and measure the angle. So I select number 4, but everyone does it differently. So what we can do is measure the interior angle of those 2 lines and the alternate angles. So I'm still in angle mode, so I can keep measuring all the angles that I want. And press escape. And students say, yep, okay, doesn't move. Let's move the angles. Oh, sorry, move the actual parallel lines and points. I can move it around, and there we are. Now, under the settings menu, so let's go to the menu. So we have settings down the bottom here, and we select settings. So at the moment, I'm going to 3 digits. I've got the degrees. I'm going to just move down, and look at this down here, automatically label points. So I can select that and make it default anytime I want. So we can set it up for ourselves for our individual documents. So I can cancel that. So with geometry, be creative. create a document. Students can actually follow through with it. You might, in the classroom, create that very quickly. They like to do it with the junior students, like Year 7s and Year 8. I like them to actually create the actual angles for themselves and lines, and they do the measurements from there. So with all that summing up, so talking about what I said, the first one, with about the area and measurement and move it around, we can actually come back to it and think about what's the area, reinforcing about base multiplied by perpendicular height divided by 2. We can put a parallelogram on top of it, rectangles, and it's about just being creative. So what I might do now is pass it back to John to continue the wonderful night. We've only got an hour, John. Wish we could have more time. So I'm going to stop sharing.
They do say that time flies when you're having fun, Rodney.
It does, doesn't it? Okay. You should be ready to share your desktop, John.
Thanks very much.
There for you. Yeah, you're ready. You're on the go. So you're in charge now.
Thank you, my friend. Very nice. I really enjoyed that. And I think that fitted in nicely with what we were just talking about in terms of the area. I really like that reinforcement to the students of actually what's happening. So that was great. Thanks, Rodney. All right. So back to the iPad app. Now we're going to look at another of the contents descriptors from the Australian curriculum in Year 7, describing translations and translations, reflections and axes, rotations and multiples. I was just thinking whether I was going to the right one there, Rodney, for a minute, but I think that, let me just scroll down and have a look here. Yep, perfect. That's okay. Exactly what I wanted to do. So, I was engrossed in yours so much. So to do this, and we've got all those transformations in here. We've got symmetry, reflection, translation, rotation, and dilation. Interesting that they use the word dilation. Do you use the word dilation much with your students, Rodney?
I do, actually, because I always related back to science with regarding like the pupils of animals, humans, cats, etc., talking about dilating the pupils and related back to there.
Very nice. Yep, I like that. So we're just going to go through a couple of these. I'm also going to show how this links quite nicely with the relationship between the rectangle and triangle formula as well. So let's start with probably my favourite, which is reflection. So obviously, if we're going to do reflection, we need to have an object. So let's go to our MassDraw. Rodney, are you finding you're using the MassDraw more than you were before, or do you still stick with shapes?
It all depends what I'm doing in the classroom. So if I want something very quick with the software, I can draw it quickly. Sometimes I'm prepared. The teachers are prepared. We're always prepared for our lessons, aren't we? But I'm tending to use the MassDraw a lot more these days. Yeah.
And here I say I'm using the MassDraw and I go back to using the polygon. So there's the polygon I've just created. Obviously, if I'm going to reflect it, then I need to reflect in a line. Again, I can either use MassDraw or I can use line. And then we're going to reflect that shape. And I find that this, before I do that, obviously you can talk to students about different shapes, but again, really nice to get the students to think about, okay, if I am going to reflect that shape in that line, what's going to happen? And get them, and what you can do is you can actually send them that as an image, or even print it out onto a piece of paper, and get them to draw what they think the reflection would be. That probably obviously wouldn't be the best one because it's parallel there, but maybe something like that, and get them to actually draw the image of that on the other side of that line, or where they think it would be, even perhaps choosing points rather than anything else. So that's a nice thing to link the actual physical using pen and paper with then using the app, and then you can actually show them. You go back into tools, transformations, reflection. Again, if you're not sure about what to do, we've got reflection up here in the right hand corner. Tap the line of reflection and then tap the object to be reflected. All right, tap the line and tap the object, and there we go. We can now see that it's slightly off the page. Let's just bring it up a fraction, but we can now see it. At this point, I like to change the colours of one of them because I don't want them to clash with each other. I want the students to realise that they are different, that the red one's the image. It's quite nice like that. And if we'd actually labelled those points when we reflected it, and I'll show you that in a minute, it actually puts them as in transformation terms with the A dash, B dash, etc. That's quite a nice function as well. And again, you would say to the students, okay, if I'm going to grab, let's say, let's just label it, point A up here, then what's going to happen? If I pull it towards that line, what's going to happen? And we've got a nice image going on there that the students can see and experience what happens. Again, stopping it short of that and then saying, well, okay, what's going to happen now if I grab that image, grab that point A and I put it past the line? Bit weird when you use the analogy of mirrors and thinking about going through the mirror. I'm sure we could find a video clip or something like that anyway. But again, a nice image of showing it cutting right through, and the students can look at how that works. We can look at measurements on those as well and angles on those and see that they're exactly the same. So that works quite fine. And then we can also talk, if I grab that line at the top and I move that line, what's going to happen to the shapes? And again, we've got some nice images coming on, and we can talk to the students about that. And they can just have a play with it. Ronnie talked earlier about students having a play with things. And I think there's nothing wrong with the students having a play with these. And then again, because they can actually take photos of these screens, I've used it before where I've got the students to create like a little poster or an assignment piece using these images and writing to explain what's happening and why it does what it does. Rodney, anything you want to add to the reflections?
No, that's good.
Okay. So what we can also do, I've got one already. Where did I put it? Here it is. What we can also do is, here's one that, famous, I suppose. I was going to say Blue Peter there, but that's showing my Englishness. I'm not sure. See if we have Blue Peter over here, Rodney? No Blue Peter?
No, I don't really use that.
Here's one I created earlier. And here, obviously, you can see that we're doing enlargement. It's already created. I may send this file to the students already. Or equally, I may ask the students to create something like this, and then they could actually potentially send that to me. They can either send that to me via an email, or they can put it into Dropbox or Edmodo, so they can actually send me their homework quite quickly from this again. But you can see here now what I've done is I've linked a slider to this, and I've just got some measurements on there. I could add more measurements if I wanted to. Down the bottom here we've got the length of that's the diagonal side, and its corresponding one on the red triangle. And I've done a little calculation here to see, again, like I showed you earlier, when we put an expression and then we use calculate to show how we can link that as well. And I've also set the slider up so that, the segments go from 0 to 5, and it moves by a half. And again, we've got a nice little action. Oops, that's where I was going to go to. There you go. So we can, I showed you there. I've set all that up. And if I now grab it, a really nice visual. And we could build this up. We don't have to go straight to the slider. I always think it's quite nice to say, well, what is 0, what happens? We can see it moving out as well. And then we could also trace those points and see what happens to those points, and we would actually see, obviously, that those points would go in a straight line as well. Again, Rodney, anything on there you'd like to add to that?
No, I'll probably do the same sort of thing shortly anyway with the calculator, but I won't repeat it, but along the same lines. I
reckon it'd be better as well, though, mate, if you don't mind me saying so. Another nice one that we could also talk about while we're here as well, which I just thought about now, is that we could measure the area. This is one that always catches my students out. They can't work out why the area of this one, whoops, got the wrong one. There you go, let's grab that one out. Oh, it is grabbing it. Is it weird? I know why. Do you know why that is, Rodney? Why won't it let me grab it?
I think you're on top of each other. The two texts are very close to each other, John, possibly.
No, not the reason. It's because if you top right-hand corner, I've still got the area function still locked on my calculator. So
true.
There is that one. Let's turn that off. You can't go to sleep during this, Rodney. You've got to be on your game the whole time, mate. You're my wingman. I need you to look after me.
Past my bedtime.
So again, we can see now, and students may not see what the relationship is between those two numbers. They may do, they may not. But again, we can set a little. We could say, well, okay, let's have a look, see if there is anything going on here. So we can do another little text box like I showed you earlier, but I think it's quite nice. These are all things, just adds to the students' understanding of actually what's happening. No, there we go, beautiful. And if we go to calculate, expression, select a value for n, so that's the bottom one, the denominator, let me choose that one there, and r, and we get 9. And that's interesting. There's my v value over here, my enlargement 4, 9, there we go. Something's going on, and we can find a nice relationship between those two happening there. And to finish with, for my part, I was going to show you earlier, here's my go at using the rectangle and the triangle way, again using some measurements, but also I've animated point E, and by animating the point E, I compress it, the students, again, notice the numbers on the right aren't changing, or obviously the calculation to make those numbers is changing, but the actual answers aren't changing. So the students, again, may not believe that that's actually anything's happening there. So you could add more dimensions, but I just added a length DE to show them that as that is moving, at least that's moving, and we can see that. So maybe I perhaps would add to this the area of triangle ADE, and maybe add the area of triangle ECB, and show that those are changing, and see that as you're animating that those are still the same numbers. Let me just stop that animation. And going to the second one, here again, and a little bit more gone on in this one, but again, what I want to, and we've discussed, I'm sure, as teachers, many different ways, but what I'm trying to show here is that those two triangles, the yellow one there is the same as this half of, not half, but the left-hand side of that dotted line of the orange one, and likewise that those two are the same. So again, what we can do here is we can use rotation to show this. And if I go into transformations and rotation, again, not sure about the syntax, so let's go to rotation, tap the object, tap the location of the rotation point, and then tap the rotation angle. You'll notice that over to the right-hand side, I've already put 180 in. We could set that up with a slider, so we make it turn slowly. But let's just go here and here, and we can see that, although perhaps the students wouldn't see that it's on top, we can see that there's D1 down there, there's E dash, sorry, not 1, and there's A dash, and it has rotated all the way around, and it's the same shape. And therefore, if they're the same shape, they must have the same area, and therefore the area of the triangle is half the area of the rectangle. Anything you'd like to add to that, Rodney?
That's wonderful, isn't it?
Thank you very much.
Nice to you, yes.
Well, and I think on that note, I will then pass back to Rodney, sharing the love. So I'm just going to pass that back to you, Rodney, now. And Daisy, are there any questions that are coming up from people?
No questions coming through at this point.
So please, if there are any questions, please put them in the chat window, and we can answer them. Or if you try some of these things later and you're not sure how to do it, please email myself or Rodney. You can get our email addresses off the website, or contact Daisy.
That's great, definitely. Okay, very quickly, regarding what John just before, but do the same type of thing. I don't want to repeat it and go through it, but I'm going to do what I did before and actually add the grid and the dot grid. What I'm going to do is add a polygon. So over here I'm going to add a polygon. And come back to the finish, and if I press escape, and I'll say to the students, and I might have this file to start with, and I say to the students, I'll either use the navigator to set it out or get them to create one themselves and copy on the screen. And I say, if I reflect that in the y-axis, what would it look like over here? What if I did a double reflection? What would it look like down to here? Where would it go? So what the students could do is actually use the same thing and create their own polygon in this quadrant here and see what it looks like when they reflect it and reflect it down here. Or if they're really adventurous, they can actually draw it down here ready to go. So the students would actually, to double check their answer, I won't actually put the trial guess. I would actually say, okay, what are we doing? So we want to actually do some transformation, and I want to do some reflection. Now, before I go any further, I might want to use the same diagram with a dilation or anything else at all. So what I could do is press Control up to go to the page layout, and I've actually inserted it within my circle geometry page, and I'm about to show you shortly. What I could do is just go Control C and then Control V. I can actually paste it. If I do it again, I've got the phone in one hand, the mouse in the other hand, and I'm actually having troubles here. Should paste it there, should copy it. I'm not too sure what's happening there, so I hope someone could tell me why I'm going wrong, because you always copy it. It's technology, it works all the time. Now, so what I could do here is actually, let's do some reflection. So I'm going to select my polygon. I'm going to click on the y-axis, and there you go. I'm still in reflection mode. What I could do is come down to here and reflect it in the x-axis. Oh, forgot to actually, there it is there. There we are. So hopefully students would have got it correct, and we can always do a few things. Now, what I can do there, if I just press escape out of that, is if I want to enlarge this, so I might actually grab my plane and move it down. And notice how it actually grabs the plane by clicking down, like scrunching the paper and moving it down. So what I might do, I might actually increase this by a factor of 2. So what I could do is press the menu and let's go to transformations. What am I going to do? Dilate it. And we're not sure what we've got to do, so we come up and have a look. It says click the object, then to dilation center, and then the dilation value. So we could actually click the object. Let's do it from traditionally the origin, and let's say let's double it. And press 2 and press enter. That's great. And we think, okay, like we do in class, we get the piece of paper and we say, don't we normally actually measure from the center through to the point to the other end? So let's just press escape for the moment. So what I'm going to do is, like John just did before, is go to points and lines. Let's just do maybe a line. So I'm going to start here. And it just reinforces that the dilation center passes through the vertices. We can do some measurements. We can measure the length from here to here to here and see it the factor of 2. We can do a lot of things, and you think, okay, what if I actually grab one of the vertices? What's going to happen? Love dynamic geometry. You're in the classroom, the student says something, and you go with it. As experienced teachers, we do that. It's about being comfortable and using the technology. We can actually use that. Now, you notice that I've actually added this page to my circle geometry document. So with my Year 10 class, I wanted the students to develop the circle geometry rules for themselves. So what I did, I created quite a few pages here. So all I'm going to do here is let you have a look what type of pages that I've created for the students. So you'll see the next page. Quite a few pages, or if you use the computer, we can just click up to here.
Actually, Rodney, we've had a couple of questions come in that you might want to consider as you're showing this. Okay.
I'll create some of these very quickly and the time that we've got as well. So any questions, Daisy? As
yes.
we're going through that?
Yes. This question came through when you first started, which was, are you able to label their coordinates? And then you have another one that says, is dilation different from dilation from the X or Y axis?
With the dilation, it's actually a point. It's on the actual, we select the point, dilation point. So I went back to the one beforehand. If I actually just escape out of that and just go Control up, I hope I'm answering the correct question, and go to here. Have you noticed that my dilation center was here? So if I actually went to here it would actually dilate double the size in that direction, the ray from that point. Is that the correct answer, John, you would say?
Yeah, I'm not sure. Is that what this person's asking, Daisy?
Not too sure.
I believe so.
Yeah, so I just picked the origin as traditionally that we do, and we can rotate around the origin. We have in Year 7, Year 8, we can rotate in a clockwise, anti-clockwise direction. We can do the same thing. So I just, for that particular example, chose to use the centre of dilation as the origin. I can pick a point here and dilate it out. So why don't we do it? So let's have a look. So menu, geometry, transformation, dilation. We click the object. Let's pick the point, and we say, let's do double, press enter. There we are. Imagine if we actually go from that point through the vertices, and actually would be double the size. I hope that answers your question. We've actually called in or emailed that through on the line we've got here.
I'm just asking.
Can you also show people how you add that coordinate to each of the points as well? I can show them later on the iPad, but can you show them on there how you add a coordinate to one of those points?
We'll do that later on. Okay, so but you get out of that. So as we went through here, I love these two rules. Obviously, I call it the butterfly rule. A lot of people do. The girls called it the bow tie rule. And I mentioned this rule here. I said, Star Trek. And they looked at me. And they said, it's an arrow. I went, okay, all right. We'll call it the arrow rule, but the students, they name it how they want to name it. So how I created some of these with these particular diagrams, you can see they've actually got a polygon and it's centre of the circle. So, and you'll notice that there's text here. See this text here? You notice how it's actually joined together? So I'll show you very quickly while we're here. So what I might actually do is actually insert some text. The actions, I can insert text, so I can right-click and add text. So I might do is say, your name's mentioned here, John, posterity. So if I press enter, and then I'm going to move I'm going to add, say, Daisy. Let's have a look.
Careful now. You're linking me and Daisy, is that what you're saying?
Okay, how about you and me then, okay?
I know you're talking.
All right, so what I might do is actually enter that and press escape, and I want to join those two text boxes together. So let's move that around. So let's have a look. Grab that, move it over here. Now, I want to join this to John. So let's move over to here and think, okay, so
it's all wrong there.
Join myself to John. So it says attach. See, I right-clicked, and we're going to attach it to John. And I know we're being silly here, so with our names, I'm going to attach that. If I click on that, and you'll go, right, where do I want to attach that to? So it's a shame my middle name's John, so I should have actually said Rodney John. So John, sorry, mate, I'm actually going to attach John to the back of my name. So I'll attach that, and you notice that I can attach it to after me, or down here, or in the corner. So what I'm going to do is click it onto here, and if I grab that text, there we go. So text. So what I've got here is 3 text boxes joined together. So when I typed it to fit it on the screen, I actually joined it and I can move it around. Okay with that? So you like that instruction? Now there's a PDF that I put some instructions together that will possibly come out to you. So I've got some instructions how to attaching text boxes or other text boxes, slider values within text as well. So little instructions to go. So getting back to constructing these, so I want to insert another geometry page. I want to insert a circle. I click and just move my cursor to the right. So I've got my circle. And what I'm going to do then is, we're talking about angles subtended at the circumference with the corresponding chords. We like the students to remember the words, but they love the symbols. So what I'm going to do now is put in a triangle. Click on the circumference, move it over to here, and click on to circumference. Okay, so we can actually add the triangle to circumference. So we can do lots of things, can't we? So if I can press escape now, and if I move it up to here, now we're looking like a triangle. So what we can do now is I'm going to add another shape. Let's add the triangle. And I've got diagram quite easy to do. So very simple to add triangles, as we call cyclic triangles or cyclic quadrilaterals. Very easy to do that. So if I click on these diagrams, you can see that I've actually joined up with line segments to create the butterfly. So as I say, my instructions say the students use the angle measuring tool to measure each angle's circumference. Okay, so we come to here and we go to the measurement, the angle tool. So let's measure, as we know, the angles we are interested in. And we come up to the other point on the circumference. And the beauty of the dynamic geometry is you've got the angles and it says, let's move the points. And we move all the points and they say, we don't believe you. So we move down here and we start moving the points. Isn't that just beautiful? So very simple construction. So they've actually developed their own rules. That's why I love using Nspire with the junior students, not just for the senior students. They develop their rules, like with index laws. I love deriving index laws with the junior students. So as we go through, that's a bit of fun where you can actually have the angle subtended, the circumference on the diameter is 90 degrees, and you can actually see a circle traced out. So I just put that into a bit of fun, students like that. And one of my favourite constructions, obviously, is add a perpendicular bisector of the chord. The students say, perpendicular, bisector, we can talk about what a bisector means. We can actually find the midpoint, then put a perpendicular to it. So what we can do is a construction. Okay, it's getting a perpendicular, and they want a perpendicular bisector. So we come over to here. Beautiful, and you know what's going to happen now. And press escape. And if we grab the points, isn't that beautiful? So it reinforces some of the circle theorems that we have with these relationships. Now, you can create these, or what you could do is actually head off to the TI Australia website. For example, we come into the Australian website, we click on Teachers, and you can select the curriculum inspired. And you think, okay, what year level am I teaching? Something year 9, possibly I could use in year 8. So let's click into year 9. Click onto measurement and geometry. And there's activities here ready to go. You think, what do I need to do? So maybe I can look under similar signs, for example. I can use that as with dilation. And you see the example here that we've got triangle. Looks like we've actually got sliders to make it bigger. So let's investigate it. So we click on a similar signs and we wait and we think, okay, have a read and see what's there. And there's all these files here. So what we could do, we could very quickly in the classroom, see how quick it is. Imagine I'm actually talking in the classroom. Click on download all files. Depends how much. Oh, there it is. She's ready to go. And I can actually send it straight away and download those files as I've seen it. What you could do is actually, let's open up a TNS file straight away. And there it is, ready to go. And we click into here. There you are. Then if you have the navigator, which I love, I can actually send it to my students. That was very quick. You're in a classroom and you say to yourself, let's maybe change it to computer view. Then we can actually use the slider, what John was saying, create your own slider and start doing measurements. Someone's actually created these measurements for us, and there it is there. So you've actually got creativity for yourself, what I've shown you just before, with all the other documents. And I love the cyclic quadrilateral, talking about opposite angles of a cyclic quadrilateral or supplementary. We can move it around. Getting close to finish time, isn't it, John? It's sad to say good night to everybody, isn't it?
It is. I know. How are we going to cope this evening?
This is the one I'll show you very quickly. The reason why I love this one is we measure the angles that we want to say. We know we students measure all the angles, so we measure the angles. And the reason why I love this one, because often in the textbook there are these unusual diagrams. And what does it look like? I say, let's move the points. So let's move it around. Ooh, tricky. Be very careful here. When you move it around to here, what's happening with the actual points, you can actually talk about what these angles. And as you see here, the geometry, it's actually rounding to. I've got it rounding to 3 significant figures, so a little bit out. But when the students actually start measuring it and measuring the angles, you can say, how does that relate back to that there? And you think about how does it do that? And that's why I love the dynamic geometry on the computer and the handheld. The students can start measuring. You can actually see how we've got that down. So like before, I can come into here and go into settings and check it, make sure it's actually maybe float. Has it got 2 integer values? So it's all about investigating for yourself and looking. So I'm sorry I've gone a little bit too long, John. So in the PowerPoint earlier tonight, there was actually an example of a file that was circumcenter. So what I could do, I think I've actually got one here is, I think there it is there. Open it up. And a viewer actually created solutions. So you may have actually looked at the PowerPoint and thought, okay, how can I use the CAS engine? How can I use the computer? I looked at it myself, the question, because I looked, it's a PowerPoint, it's an interesting question. I did the solution up myself and checked it and rang people and just wanted to make sure of myself. One way of doing it is actually constructions on the calculator or computer. I personally would have done this myself. I looked at the actual radius of the actual circle with the circumscribed triangle and found the radius, but this is one person's solution, and you would see that eventually the area of the triangle is ABC, which was XYZ over 4 multiplied by the radius. I can interchange the radius with the area of the triangle, use the Heron's rule, and I've got it. So I hope you've enjoyed that particular question that you've done in the PowerPoint. You may have had time to do that. But, yes, there's lots we could look at, and 1 hour goes quick, doesn't it, John? We had so much fun, haven't we, mate?
It is. Thank you very much, Rodney. I very much enjoyed that. That was great. And I'm about to start some circle theorems with my Year 10, so I'm looking forward to using some of the stuff that you got there, Rodney, so thank you.
Sorry, John, did you want anything to show towards the end, mate, there? Like, I want a bit further.
Daisy, I can very quickly show how we can open documents on the iPad, but I think it's pretty obvious.
There you go, mate. It's all yours. There you go.
Just while you are handballing to John, we've had a question about 3D shapes and if it can be done on TI-Nspire.
Most certainly can.
Yep.
Most certainly can. So
I can show very quickly on here the 3D shapes as well. So one is about the point. When we talk about the point, notice that with these points, because we're using grids, that the point moves between the whole numbers. And we can
John, we can't see your screen yet.
Ah, sorry. Oh, there you go.
Okay.
You were just so excited. You were so excited, John.
I was so excited to tell you what to do. I got carried away. Good job you're there, Daisy. Right, hang on a second. Oh, blimey, look at that. It went so smoothly. I know I've lost my mouse. Oh, my Lord.
That's all right.
My mouse gone. There it is. Right, my mouse has run away.
There we go.
There we go. You see my desktop now?
Yeah, it's just coming through. Now we can, yeah.
Beautiful. Thanks, Daisy. It was just the excitement of it all. So a couple of things. One is the coordinates. So here's a point. Because we've got the grids, when I grab that point, it will only move it by integer values. If I tap on that again, then coordinates come up. And because it's dynamic. Oops, what happened there? Get off that. Because it's dynamic, as I move that, all the values will change on that one there. Talking about 3D stuff, I can show you on here. It will do it on here. If we go into the spanner and go graph entry, view, we can do 3D graphing, and we can do 3D imagery like that. And I have got a little one to show you that on this one. Let me just get out of this and go to my CAS one. I think it's on here. Yeah, there you go. This is one that Steve Arnold gave me, and this is very much using the 3D capabilities of the Nspire. And just to finish for me, for the same thing as what Rodney was talking about, if I go to the website as well, and go to the TI-Nspire website for us, and this works very nicely. I've chosen one here from Year 7, one of Russell's favourite ones with the hands. If I just click on that. Oops, there you go. My wife's updated. We've got dance rehearsals. Everybody knows about that now. We're okay. There's all the files, like Rodney said, to the right-hand side. But if I click on hands-on reflections, because it knows that I've got the app on my iPad already, it can say, "Does you want to open it?" Thank you, Rachel. It's very nice of you. It opens it straight away into my app, and all the documentation that I need to do and follow that is on all those pages. Daisy, that is it from me. I think that unless I'll pass it back to you, Daisy. Is that okay?
Fantastic, sure.
And a good night from him, if you think of the two Ronnies too.
Okay, just one moment. Well, I'd like to thank both John and Rodney for their time tonight and for sharing for us what they do in the classroom. I'm sure that you all, as audience, gain something from this evening. Rodney mentioned some files. Those files will be sent with a thank you email for attending and your certificate link within the next 48 hours. And thank you to you, the audience, for listening and giving up your time tonight. And I think that's it. Have a lovely evening, and thank you very much once again. Bye-bye.
Thanks, Daisy. Thanks, Rodney.
Thanks, John. Good evening, everybody.
Oh, well, good night.